Okay, final two questions from the turn-in. Once again, we're looking for the equation of a line tangent to curve, and you're given the point. So I can start off with y minus 8 is equal to m times x minus 1. Okay? Now I'm looking to take the derivative because I'm looking for the slope. So dy dx, which is your derivative of y with respect to x. This is a pretty easy to chain rule, but we start with the power. So 3 times the something doesn't change, to the power minus 1, that's a 2. And then we multiply it by the derivative of the inside piece, which is 2x. So I'm going to get dy dx is equal to 2 times, or 3 times 2x, we can simplify, and then x squared plus 1 squared. Now we want this value when x is equal to 1. So this is going to become 6 times 1 times 1 squared, which is 1 plus 1 squared. So this is going to be 6 times 2 squared, which is 24. So this is my m. I bring it up here, y minus 8 is equal to 24 times x minus 1. Y minus 8 is equal to 24x minus 24. Distributing the 24 through, adding 8. I get y is equal to 24x minus 16. Final answer. And we should feel pretty good about that. And we get to the last one. Last one looks ugly. Let's see what we got. So we are going to work with this. There's a couple different ways you can do this. What I'm going to do first is I'm going to find the y coordinate. So I'm going to go with y is equal to, I'm going to plug the 1 in, so 4 times 1 divided by the square root of 3 plus 1. So this is 4 over 3 plus 1 is 4, square root of 4 is 2, so I'm going to get 2. So the point I'm playing around with is, or the point of tangency is going to be 1 comma 2, so I know that y is going to, so y minus 2 is going to equal m times x minus 1, because again we're looking for the line tangent to the curve, so that's what I'm going to come back to. But now I have to take the derivative of this, so dy dx is equal to, and again, do it in pieces and just be careful. Remember that this is really to the 1/2 power. So I'm just going to write it over here, 3 plus x squared to the 1/2 power. I just want to see that as I take the derivative of it. So I'm going to start with the derivative at the top. That's easy, that's 4. Times the bottom. The bottom is 3 plus x squared to the 1/2. Then minus the top, or x, times the derivative of the bottom. This is where it becomes complicated. So it's minus, and I'm going to put a parenthesis around this whole thing. So the derivative of this, so you start with the power, 1/2. The 3 plus x squared doesn't change. Power minus 1 is minus 1/2, and then that has to multiply the derivative of the inside piece. The derivative of what was being raised to the power is just 2x. Alright, so here, what's probably, well, let me just try to simplify it a little bit. 3 plus x squared, and that's the 1/2 power. All this is going to become a minus. I have 2x times 4x is 8x squared. Half of that is 4x squared, and that's going to be multiplied by 3 plus x squared, but to the negative 1/2. Alright, and so now I want to find the slope, and I'm looking for the slope at the point where x is 1. So dy dx is going to equal 4, parentheses. This is going to be 3 plus 1 squared, that's 4, and then to the 1/2 power, that's the square root of 4, so that's 2, minus 4 times 1 squared is 1, So 4 times 1 squared is 1 times, now here we go again, now we got to be careful. This is going to be 3 plus 1, again, which is 4. The square root of 4 is normally 2, but it's to the 1/2 power, so this is 1/2. So this is going to equal 8 minus 4 times 1/2 is 2. Answer 6. So it works out really, really nice. So I have y minus 2 is equal to 6 times x minus 1. So y minus 2 is equal to 6x minus 6. I'm going to add 2 to both sides, and I get y is equal to 6x minus 4 as your final answer. That wasn't too bad since I didn't have to simplify that derivative too much. I was able to just plug in that x equals 1 and things worked out really, really nice. Okay, so there's your turn-in. Those people who have corrections to do, please try to get them 3 times each to me tomorrow. And this will help you study for the test or for the midterm as well. Okay, your midterm's in the afternoon, so you have some time. All right, have a good night. Good luck studying.